Okay, business algebra, let's continue. Now, sometimes it doesn't come to you in fully graphed form. Sometimes you have to graph it yourself. So let's talk about graphing f of x equals 2x cubed plus x squared minus 6x, really sketching it. We'll get the key factors right again, but it's sketching it. Okay, so how do I factor this? Here, I can factor out an x. Then we have 2x squared plus x minus 6. Which means I need the factors of negative 12 that add to 1, which is 4 and negative 3. So 2x squared plus 4x minus 3x minus 6. If I factor by grouping, the first two share a 2x and leave an x plus 2. The second two share minus 3, leave an x plus 2. So my factors are x, 2x minus 3, the outsides, and the x plus 2 common factor. So what does that mean? When I set them all equal to 0, I get x equals 0, 2x minus 3 equals 0, and x plus 2 equals 0. It's the point 0, 0. This is x equals 3/2, which is the point 3/2, 0. X equals negative 2, so negative 2, 0. Okay, so I plot those three. I also already have the y-intercept with 0, 0 again. So negative 2, 0, 0, 0. 3/2 is 1.5, 0. So let's talk about this chart that we did in the end of the last problem a little more extensively. So the idea behind using the chart is the only places that I can cross from a positive to a negative are 3 zeros. Why? Because in order to get from a negative number to a positive number, I have to at some point cross 0. Similarly, to get from a positive number to a negative number, I also have to cross 0. Which means any number between these values, if one of them is positive, they're all positive. If one of them is negative, they're all negative. So if I plug in a single point, it can represent the sign of all of the numbers in that region, which is how this really works. So if you don't like the plus minus chart, plug in actual numbers and plot them. So we've got negative 2, 0, and 3/2, or our 3 middle points. Now what can I plug in between those values? Easy numbers between negative 2 and 0 be negative 1. Between 0 and 3/2 would be 1. Bigger than 3/2 could be 2. Smaller than negative 2 might be negative 3. Get their actual values and plot them if you don't like the plus minus chart. So let's talk about f of negative 3. You can plug it into the original or the factored version. I'm going to plug it into the factored version. I think that's easier. It'll be negative 3. 2 times negative 3 is negative 6. Minus 3 is negative 9. Negative 3 plus 2 is negative 1. When I multiply these all together, that would be negative 27. So that means I have the point negative 3, negative 27, which is, of course, off the graph. But what that tells me, though, is it's off the graph off the bottom. It's a negative number, of course, which means it has to go down from here, and it would be off the graph. So I can't even graph that far, but I know way down here it would be there. What about negative 1? Gives me negative 1. 2 times negative 1 minus 3 is negative 5. Negative 1 plus 2 is 1. So negative 1 times negative 5 times 1 is actually positive 5, so we get the point negative 1, 5. That you can actually plot. We have negative 1, 5, which means it has to go up from here, but it also has to go back down to 0, 0. Let's plug in positive 1. We get 1. 2 times 1 minus 3 would be 2 minus 3, which is negative 1. 1 plus 2 is 3. 1 times negative 1 times 3 is negative 3, so we get the point 1, negative 3. So this one was positive, this one's negative. 1, negative 3. It's about down here. This means it has to go down before it turns around and goes back up. And lastly, we can plug in 2. It gives us 2. 2 times 2 minus 3 is 4 minus 3, which is 1. And 2 plus 2 is 4. So 2 times 1 times 4 is 8. So we get the point 2, 8. Of course, 8 is a positive. But we can plot 2, 8 up here. We know the graph must go up. And it has to keep going up because if it were ever to turn around and go back down, there would probably be another 0. So if you find the method of memorizing hard and you find that plus minus hard to use as sketches, just plug in points and see where they would be. On your homework, I'm pretty sure they have you plot a certain number of points anyway and it will create the shape for you. So it's never a bad idea. Or they put it in a multiple choice form so you can get some kind of idea of what this looks like. Okay, let's talk some word problems. The pressure of the oil in a reservoir tends to decrease over time. The pressure is given by the function t cubed minus 32t squared plus 256t, where t is measured in years since the initial reading. Find a few readings and make some generalizations about whether it's increasing or decreasing between p equals 0 and 4 and 12 and 16, 20. Okay, this is a fancy way of saying that I want you to plug in all of those numbers. And we'll not be offended if you want to use a calculator to plug these all in. Now, what's p of 0? Because there's a t in all these terms, it's just 0. Plug in p of 4. It's 4 cubed minus 32 times 4 squared plus 256 times 4. That's 64. 32 times 16, that's minus 5, or 12, plus 1,024. All of these things together is 578. So you would assume, because it went from 0 to 578, it was increasing, because the number increased. P equals 12. 12 cubed minus 32 times 12 squared plus 256 times 12. My easy way to do this is negative 20 times 12 squared plus 256 times 12. That's negative 240 times 12 plus 256 times 12, which is 16 times 12, or 192. So it looks like it went from 578 to 192, which means it got smaller. Then you plug in 16 and 20 as well. I don't know why they have you plug in. This is factorable technically here. P of t equals t times t squared minus 32t plus 256. Namely, this is t times t minus 16 squared if you factored it. And that means that our zeros in this case are 0 and, well, I don't know why I said to the 12th, t minus 16 squared. At 16. And between 0 and 16, if those were my only two zeros, you can see I plugged in the number 4 and I got a positive. Now if I plugged in the number 20, I'm pretty sure I would get a negative. But I could also get actually I'd probably get a positive there because this is a double root. But the point is, if you plug in values, you can see if it's increasing or decreasing. But you know that the only places it could possibly change value are listed here. But they're really having you guess and check. So I think it's just going to be a rough multiple choice problem on this one. But just you plug in values, you can kind of play around with it. There's ways you learn later in calculus that help you actually find where things are increasing and decreasing. I just think the problem's kind of out of place. Now, for the problem you see like number 5, remember that profit equals revenue minus cost. And so when you have polynomials in this function, you will just combine your like terms when subtracting. And that is all for 3.5.